Hello future engineers and my dear students, welcome back to Mudassir Academy. I am Mudassir Sheikh. Today we are going to learn about Legendre's linear differential equations. Now see, both the Legendre's and the Cauchy's linear differential equations is a continuation of what we have been learning under differential equations of higher order with Cauchy coefficients. Now in a very simple way, I can put like this. See, both the Legendre's and Cauchy's differential equations are a special form of linear differential equations which can be converted to the d operator form. So like equations like d including terms like d square, d cube, so on. Now once you know it is of d form, you know what to do. The solution is simple. Y is equal to complementary factor plus particular integral. Getting it? So that means what? For this also you need that what you learned previously. That means you need to know the complementary factor and according to VTU syllabus 3 different types of particular integrals compulsorily. That means if you haven't watched those videos, then please go watch them now. You can find the link in the description below or please refer the playlist. Done? So in today's class, we will be focusing only on Legendre's linear differential equations. The Cauchy's we will be doing in subsequent videos. See, I am going to make this concept as simple as possible. So you get your pen, your notebook ready and practice along with me, and so that we can solve each and every problem systematically. And if you are new to this channel or you have been following me, then please support me to make more and more meaningful videos like this. Even though I am undergoing critical health condition, please share these videos with your friends and classmates as much as possible, and please don't forget to subscribe. As I told you, the Legendre's differential equation is a special form of linear differential equations. See, in a very simple way, the Legendre's equation, the question looks like this. It will be like ax plus b the whole cube into y triple dash plus ax plus b the whole square into y double dash plus say x plus b into y dash plus y equals say something 5x right hand side. Okay. Now the question given looks like this. Say for example, question like it can be 2x plus 1 the whole cube y triple dash and 2x plus 1 the whole square y double dash, like this terms, or x plus 1 the whole square, x plus 1 y, so on. Fine. The question will have x plus b terms, repeated terms. But remember one thing, there should be cube, there should be y triple dash, square, there should be y double dash, and 1 there should be y dash, so on. This is how to identify a Legendre's differential equation. Equation like this will be Legendre's. Ax plus b form or 2x plus 1, 3x plus 2, x plus 1, something like that. Clear? Now, how to solve this Legendre's differential equation, and as I told you, how to bring it to D form. Listen carefully. I am going to explain in a very, very simple way. Please pay your attention here how I am going to do it now. See, first, whenever you have in the question Legendre's differential equation, or you are able to identify that is Legendre's differential equation, then what you need to do first is, see this, first this term, x plus b, no, they are repeated. So first what you do, put log of ax plus b equals t, correct. That implies, see, all same for all the problems. If they give 2x plus 1, take log 2x plus 1 into t whatsoever. That implies ax plus b will be equal to what? E raised to t. What is that? E raised to t, and whatever we get here, all the RHS form should be in terms of t only. So whatever question is given, the RHS should be in form of what? T. Now what is the LHS? See, put log ax plus b is equal to t. So ax plus b is to t. That means in the question RHS everything will be in terms of t. RHS I write here in terms of t. Okay. Now when RHS is in term of t, see, then ax plus b the whole cube into y triple dash is simply written as whole cube. So a cube into, see wherever there is cube, simply write d into d minus 1 into d minus 2 into y. Wherever there is, ax plus b the whole square y double dash square, simply write a square into d minus 1 into y, and wherever there is plane ax plus by dash, simply write a into dy. That's all. So all the LHS in terms of d. Got the concept now? So whatever question is given, first put log ax plus b is t. So ax plus b, or what is x, whatever it is, in form of t, you write. Left hand side, use this to write everything in terms of d. Now you will get a differential equation, a equation in terms of differential operator d's, and you know how to solve it. What's the solution? Y is equal to cf plus pi. That's how this done. Please write it down 2 to 3 times so that it fits perfectly in your head. Now we'll make it more and more perfect by solving some problems. That's it. We have the first problem here. Solve 1 plus x the whole square d square over dx square plus 1 plus x dy by dx plus y is equal to sine of 2 log 1 plus x. So I write it in the form for you to understand. Let this be 1 plus x y x square y double dash plus 1 plus x into y dash, because y dy by dx is y dash and d square y by dx square is y double dash, as you all know, plus y is equal to sine of 2 log of 1 plus x. Fine. Now what I will do is, this is what Legendre is. This is what purely see ax plus b. This is the form of what? Ax plus b, where what is a is equal to here? See, a is equal to 1 here, correct? See, x plus c, they are repeated terms, 1 plus x, the terms are repeated. So what is that? Ax plus b, 1 plus 1x is 1 here. So definitely this is what Legendre's. So it is Legendre's, and what is a is 1 here. A is what? 1. Okay, so that means what to do first? According to theory, since I have identified this is Legendre's, what I will do is that I'll put first thing is that put log of ax plus b. What is that? 1 plus x here. 1 plus x equals t. That implies 1 plus x will be equal to e raised to t, which is used where in the RHS. Okay, now see, I am writing everything in simple way here. Please pay attention. Now what I told you, if in the equation, then this, see, we have the RHS now in form of t. Can you sign in place of log 1 plus x? You are putting what? Put log 1 plus x is t, putting t. Correct. Which are convenient, either this or this, you have to put it here. Now the left side is in form of d. So what I told, square ax plus b square into y double dash is written as a square into d minus 1 into y. Wherever there is cube, d minus 1 d minus 2 into y. Wherever there is square, d minus 1 into y. Wherever y dash dy. As simple as that. That means square. So a is 1, 1 square is 1. If it was 1 plus 2x, then we would have written 4. Okay. So 1 plus 1x. So a is 1 here, as you know, in this question. So a square. So 1 square d into d minus 1 into y plus dy, again is 1, plus y equal to, as I told you, right side is in the form of t. Say I have taken 1 plus x e raised to t, I cannot take log e raised to t. So whichever conveniently fits, will take that, because I already know log of 1 plus x equal to t. So put there, it will be sine of 2t. Now simplify. So we have d square minus d plus d plus 1 whole into y equals sine 2t, dd cancels. So d square plus 1 into y equals sine 2t. Now see, such a easy thing. You all know, we have been doing this previous videos. It's a differential equation. Sine RH is a sine cos trigonometry type number 2. So what we do first here? First, always we find the complementary factor. But remember one thing, see the right side is in term of t. So be careful here. Don't write x and all. The right side is form of t here. Okay, that means first CF, how we write? The roots will be m square plus 1 is equal to 0. So m square is equal to, that implies m square is equal to minus 1. So m is equal to plus or minus I. So the complementary factor will be C1 cos of, see students make mistake here, they write x because you have the habit of writing in the previous sessions. So it is t here, right side is t, not x is not there. Okay, lastly in the answer we replace by t by x. Okay, so now finding since the variable is t here, so CF is equal to C1 cos t. Why? Because m is equal to plus or minus 1i plus C2 sin t. Okay, let's underline it as we always do to get marks in the exam. Now, what is yp? So I will write here yp is equal to sin t divided by d square plus 5. Now, it is, sorry, it's sin 2t, right? Sin 2t. Now, this is numerator is sin or cos upon f of d, which type number 2. And what we do in type number 2? Please hold on back to the previous video if you get confused. Always when the numerator is sin or cos upon f of d, always in the denominator replace only d square by minus a square. Don't test the d's, only d square. And here this is very simple. So we replace d square by minus, what is a? See here, what is a? Is 2 minus 4. That's all. So wherever there is d square, put minus 4. So we have yp is equal to, that is particular integral is sin 2t divided by minus 4 plus 1, that is we get minus sin 2t by minus 4 plus 1 is minus 3. So minus sin 2t by 3. That's it. So I got the particular integral. Now as you know, the solution is CF plus PI. So let's write a solution as y is equal to C1 cos t plus C2 sin t minus sin 2t by 3. Done. So, but it's not over it. The question is given in form of x. So, the solution also should be in form of x only. It's t here. Okay, so we need to convert in form of t. Therefore, the solution y is equal to C1 cos of, what is t? T is log 1 plus x, cos of log of 1 plus x plus C2 again sin of, again t is log of 1 plus x minus sin 2t, same thing, sin 2 into log of 1 plus x whole divided by 3. That's the solution. Right. Clearly and should be legible. So the solution is y is equal to C1 cos of log 1 plus x, because we put t as what? Which is convenient here, t as log 1 plus x plus C2 same thing, sin log 1 plus x minus sin 2t, that is a particular integral. We are adding both sin log of 2, sin 2 log of 1 plus x whole divided by 3. That's the solution. Now let's move to the next problem here. This problem is also very important. It says solve 2x plus 1 the whole square y double dash minus 6 into 2x plus 1 into y dash plus 16y is equal to 8 into bracket 2x plus 1 the whole square. Now clearly this question if you see is of the form of ax plus b. See ax plus b form, again ax plus b repeats. See the same thing repeats here. Okay, that means here what is a is equal to, tell me? If you see clearly here, a is equal to what? Ax plus b. A is equal to what? 2. So this is which form? It is definitely Legendre's form. Okay, now once we have identified 100% that it is Legendre, we need to solve. We will be applying the same technique as we had done in the same problem. I hope now you have completely understood it, and I guarantee that you can do it yourself. So please practice along with me. So first, since it is Legendre, 2x plus 1, 2x plus 1, what you do? Put log of 2x plus 1 equals t. So that implies 2x plus 1 equals e raised to t. So we use this in the right hand side. Now the next thing is, as I told you, so make it simple as possible. Okay, don't take more tension here. As I told you, always the left hand side is in d form. So ax plus b the whole square y double dash means a square into wherever square is there, d minus 1 y. That's it. Okay, so now what is a? What I told, ax plus b the whole square y double dash is a square into d minus 1 into y. So a is 2, 2 square is 4 into d minus 1 into y minus 6 into 6 is there into what is ax plus b into y dash? A into dy. That's it. A into dy. What is a? 2. 2 into dy plus 16y equals right side in terms of t. See, log 2x plus 1 is t. 2x plus 1 is e raised to t. So what fits here? 2x plus 1. So 8 into. See, 2x plus 1 is e raised to t. Use your brains. Simple maths. Simple maths. 2x plus the whole 2x plus 1 is equal to t. That means 2x plus 1 the whole square is what? Whole square e raised to 2t. E raised to t square. It will multiply 2 into t is 2t. That's it. Okay. Now we have the equation. Let's simplify this. We have 4d square minus 4d minus 12d plus 16 into y equals 8 e raised to 2t. So that is 4d square minus 16d plus again 16 into y equals 8 e raised to 2t. So again let's simplify this. It's right now minus 4 minus 12, yeah, perfect, 16. Now what I can do is, I can 4 is common, divide by 4. So take 4 outside. Okay, so d square minus 4 4s are 16 plus 4 into y equals 4 2s are 8. I take 4 common outside. So this will be what? 4 1s are 4, 4 4s are 16. Again 4 4s are 16 and divide by 4, 4 2s are 8. Done. So I have this differential equation with me, which looks very simple here. Okay. So let's solve this. Let's enjoy solving this now. M square minus 4m plus 4 is equal to 0 is auxiliary equation. Or this is m minus 2 the whole square is equal to 0. So the roots are m is equal to 2 comma 2. As you know, the roots are repeated. So the complementary factor will be CF is equal to C1 plus C2. Again, be careful here. C1 plus C2, right side is t, not x. C2t into whole into e raised to 2t. Correct. So we have the complementary factor here. Right. Now, what is the particular integral? We have the particular integral yp is equal to 2 e raised to 2t, 2 e raised to 2t whole divided by d square minus 4d plus 4, d square minus 4d plus 4. So this is what type number 1. Numerator is e raised to x, type number 1. Numerator is f of x, the function upon f, the numerator upon f of d, the function. So if the numerator is e raised to x, it is type 1. Numerator is sin or cos, type 2. Numerator is polynomial algebra x square something, type 3. So type 1, what we do? Replace in the denominator all the d's by a. Again I repeat, what I do? Replace in the denominator all d's by a, e raised to at. What is a here? Is 2 here. So what I do? Replace all d by what? 2. So we have yp, that implies yp is equal to 2 e raised to 2t divided by, replace, in place of d put 2, 2 square 4, 4 minus 4 to the 8 plus 4. See what happens here. 4 plus 4, 8 minus 8, it becomes what? 0. Now again, recall, in the type number 1, when we replace all the d's by a, if the denominator is 0, then what you do? Multiply the numerator by x and differentiate the denominator. Again replace d by a. The process follows. Okay, but here the variable is not x here, taken t here, because assumed as t. Therefore, what to do? When the denominator is 0, we multiply the numerator by t and then differentiate the denominator. Differentiate d square is 2d minus 4, 4 is 0. Again what we do? We replace d by 2. Again we are going to get it as 2t e raised to 2t divided by 4 minus 4. Again 4 minus 4 is what? 0. Again the same concept repeats. Again if the denominator is 0, then again multiply the numerator by x, that is here it is t, and again double differentiate denominator, that is 2t into t is 2t square e raised to 2t divided by differentiation of 2d is 2. That is all. 2 cancels. So we have here the particular integral as I write here t square e raised to 2t. That is it. This is my particular integral. Simple. Okay. Now, see, if you have been following my previous videos on order types, then definitely it will go in, these things will go in a flash. Or else, please go watch it again repeatedly many times as possible, then definitely it will become perfect in this. Okay, because these are all easy things, right? Now, the solution is what? CF plus PI. So y is equal to, we'll write solution y is equal to what? CF C1 plus C2t into e raised to 2t plus t square e raised to 2t. Now, the final solution will be, as I told you, the question, the problem is given in terms of x, the solution also should be in terms of x. So, as we assumed it, so we will put what is convenient here. See, first C1 plus C2. Okay, what is t? T is log 2x plus 1. Okay, so write it like this. I'll put a square bracket. Log of 2x plus 1. Okay, C1 plus C2 t. Fine. C1 plus C2 into what is t I taken? Log 2x plus 1 into e raised to 2t. I'll take this. E raised to t. Simple maths. E raised to t is what? 2x plus 1. So, what is e raised to 2t square? It is nothing but 2x plus 1 the whole square. That's it. Simple as that. Plus again t square will be, what is t? Same thing, log 2x plus 1. So, log of 2x plus 1 the whole square. Okay, whole square into what is e raised to t again? E raised to 2t is e raised to t is 2x plus 1. So, e raised to 2t squared, it is 2x plus 1 the whole square. That's it. So, you can leave the answer as it is, or if you want to further, you can write it as y is equal to C1 plus C2 log of 2x plus 1 into 2x plus 1 the whole square plus, see, you have the relation log of a raised to k k log a, correct? Log of a raised to k log a. So, log of a raised to k log a, so it will k log a. So, what is that? 2 into a standard relation 2 log of x plus 1 into 2x plus 1 the whole square. That's the final solution for this. A beautiful solution. That's it. This is how you solve it. I hope you understood this problem perfectly. So, that's all for today's video. Please don't forget to watch the next videos. I will be solving some very important exam problems on Cauchy's linear differential equation. So, stay tuned, keep following, keep watching, keep practicing, study hard. See you in the next video. Till then, bye.